Alright, hi guys. My name is Michael, and I actually work up in Waterloo in Canada.
You guess lasers?
I was hoping for that. So I'm here to tell you, like Joe said, how to port your Chrome package app to mobile using Cordova. But before that, I wanted to take an aside just to briefly go over, why is Google here today? We have like 6 contributors to Cordova up in Waterloo. And so I wanted to take you through a little story. So about a year ago, actually, I think it was the PhoneGap Day US last year where Andrew first showed up. The Chrome Apps team was working on this new version for desktop, and they were sort of well on their way. It wasn't nearly launched, but it was progressing quickly, and we started thinking about mobile. And there was no mobile Chrome Web View. Not for iOS, and there will never be, but there still isn't one for Android, and there won't be for a while. So we needed a different solution. And we had all these internal hybrid apps. We have good knowledge base on how to do that. But is that really what we wanted to do? Is that what we wanted to start? The Chrome team loves the open web and open source and sort of contributing in the community. So we asked, what's best for the open web? And so we started looking at Cordova. And aside from being an open source project that was contributed to the Apache, they were not just open source, but they were open arms. So I think there were some good ways that people talked about open source. There are different open source projects run by one organization at one time. Cordova's been just amazing. Various contributors have been very open. We got access to push to the repositories within weeks and everything like that. So it gave us confidence to work. They have a good plugin architecture, so we knew we can accomplish our goals. Great user community, and this fourth point I can't stress enough. Alright, so what are Cordova's goals and why are we here? So we want to improve Cordova's core offering, and we've been working over the last year to do that. And we want to create a compatibility layer to allow you to run your Chrome package apps on mobile. And to do that, we need to re-implement most of the Chrome APIs as plugins. And also just within Google, raise awareness for what does this community need from Google, especially on Android. So right now we are targeting iOS and Android, but we will likely branch out to others as soon as we succeed on those. Alright, so improving Cordova's core offering. I don't want to spend too much time here, but I wanted to briefly go over some of the things we've done over the last year. So there were improvements initially to the exec bridge. Andrew improved the speed significantly. We added array buffer support, so you can send binary data back and forth between your plugins and your JavaScript. File transfer, big changes, especially on Android. File system. The in-app browser, there's been lots of work there. Helping out with the 3.0 effort and the command line tooling. We're working on an app harness that hasn't been launched yet, but that's pretty exciting. And even very recently, Ian landed some bash command line completion for the CLI, which I think makes it a lot more awesome to use. Alright, so our Chrome app compatibility layer, what does that look like? So we also have node scripts for setup. We sort of took the key from the CLI. And sort of we try to use the 3.0 CLI as much as we can and just minimally route it. And then we have to write plugins to emulate the Chrome app lifecycle, the background page, parsing of the manifest as Joe showed you. So what does that look like? So you clone our repository, it's all open source, it's up on GitHub, from day one as well. And we have this MCA tool, which and you can init, which will automatically clone all the submodules and pull them self-install and that sort of thing. And then you create projects, instead of using Cordova Create, you use MCA Create to build the shell for mobile Chrome apps. And then when you enter that project, it's just a regular old Cordova-based project, so you can use Cordova to list your platforms and plugins and prepare exactly like you will from today on. So let me take you through what that looks like. There we go. So, what this is going to do is check whether you have Android or iOS set up. Install the platforms for the one that your machine is ready to go for. So this automatically adds the platforms. So this is a little bit different than the typical Cordova workflow where you first create a shell and then add your platforms and add your plugins. We will automatically see your app with plugins we think you'll need. So ideally, you want to read your manifest file and install all of the plugins that your app will need to run. Right now, we're sort of installing all of the set of stable plugins that we have. That will change in the future. So as soon as we're done here, we'll have, there we go, and we run prepare. So you can see it's just a regular Cordova 3.0 project. And we link basically the version of Cordova that we have that just makes sure that the version, there's no mismatch. But ideally, like once the dust settles and 3.0 is rather stable, you can just use your globally installed Cordova CLI. So you can do platform LS, there you go, Android and iOS, plugin LS. And so you see that we use the Cordova file API, the in-app browser, and then a whole bunch of things that we've written. All right, so what do Chrome apps look like? Just wanted to show, go to Chrome extensions, and you enable developer mode, you can load an unpacked extension. Go to demo, hello world, That's the project I just created. Here it is down here. That's what it looks like on desktop. All right? Fine, open. NX code. Run that on the simulator. It's in the background. Da-da-da-da. Oh no. So it worked 5 minutes. The demo methods. Maybe I forgot to grab it. Well, okay. Yeah, the speech demo went well, right? And this one fails.
Usable karma.
Jazz.
All right, fingers crossed. No, okay, I'll show you later. All right, let's resume. So these Chrome APIs are pretty powerful. Joe discussed briefly, there's access to sockets, push messaging, alarms, all these interesting things, hardware. And so we took a look at all of the most interesting APIs and we decided to choose to prioritize the ones that could run on mobile and would be useful to you. And so as we re-implemented them, not only did they run in our sort of mobile Chrome app framework for porting your package apps, we wanted to make sure that they're fully compatible with vanilla Cordova. So even if you're not writing a package app for desktop and not porting it over to mobile, even if you're just writing a Cordova app for yourself, we want to make sure that it's fully compatible and you can use our APIs. That's our gift to you. So the first one is Chrome Storage Local, and that's sort of an improved local storage. So local storage is bounded in size and it's rather limited. This uses the native file system, so it's limited to the size of basically whatever native apps are on. It has an asynchronous non-blocking API for bulk read writes, and it supports objects directly, so you don't have to store just strings. So this is what the API sort of looks like. Use Chrome Storage Local Set. You pass in any object key value stored, and then you can get those objects back, remove them and clear them, and you can check the size and how much memory your storage is using and that sort of thing. You can also have change listeners, so in case there are different pieces of your application, you don't have to sort of coordinate between them. You can sort of update your model and then get updates through the change listeners, and you can do things. And you can know whether there are elements that have been removed or freshly added or changed. There's also Chrome Storage Sync, which will sync across multiple devices. It's not supported on mobile now, but we plan to add it eventually. So if you write your application in terms of Chrome Storage Local, eventually you might automatically get the ability to sync across desktop and across all of your different mobile devices. The next one is Chrome Alarms, which is a sort of improved set time limit and set interval. On Android, this will actually run actively in the background and will wake your application even if it's been closed or anything like that, so you can do some more. On iOS 6, it only works in foreground, and we're working on getting it to work in iOS 7 because you get this new time slice at the end. So why I think it's better than a typical set timer is because it's sort of IP-based. You give your alarms names. You can give them an offset of frequency and that sort of thing. And so you can create these alarms, have them sort of fire every so often. You could register any number of listeners. You could query for which alarms have been set. You can clear them and that sort of thing. So you don't have to deal with like IPs and saving them globally and then clearing those. You sort of know that a certain named alarm exists and you can deal with it. Chrome Identity is an OAuth 2 flow that makes you not have to write all that code yourself. So who really likes rewriting OAuth 2 flows for a single application? I don't see any hands up. We didn't think so. So you can get off the token, which is a super easy way to get it. Google off tokens to Google services, or launch WebAuthFlow for third-party services, say Facebook. So in a normal Chrome desktop app, you have a manifest file, and that's where you specify your client ID and your scopes. For vanilla apps, we wanted to give you the ability to specify it at runtime, so you don't need a manifest file. And so Chrome Identity get off the token will pop up an in-app browser where you can then log in. If you've logged in before, it won't actually pop up. You just get it off the token right away. And the same thing for launch WebAuthFlow for third-party services. All right, the next one is Chrome Sync File System. This is an HTML file system that's backed by the cloud. So it uses your Google Drive account, but like Joe maybe didn't mention in this talk, but eventually the APIs will be open and maybe Dropbox will implement an endpoint for that as well. And so it'll sync across not only your device, but also desktop Chrome package apps if you're actually using the port when they share an app ID. It also works when offline, and it'll give you change events, and so you can continue using your app, and then it'll sync once you're back on. So your file status could be synced, pending, or conflicting, and then you have to resolve conflicts. And you have different conflict resolution policies. So this one starts getting a little bit more complicated in how the API works. At the end of the day, you get a file system just like the temporary or persistent file system that HTML5 gives you. But you can also set globally your conflict resolution policy or get status change listeners that you can then resolve conflicts with that sort of thing. Or perhaps you just want to know that, hey, there's a new file created on a remote device, and you can update it accordingly. So it's pretty useful. And you can also query for specific files for getting their status or getting the status of all your files and that sort of thing, especially if you're iterating over a directory. All right, and then the last one is Chrome Socket. And this is actual raw TCP and UDP sockets. This is not just web sockets. There's no need for a middleman. You can connect directly to various services. I was going to demo, I will not fade it in. An IRC application, which you can load up as a Chrome package app on desktop, and it's a fully web only using Chrome sockets to connect to IRC client or servers, and you can chat them as well. And it works perfectly reasonably on iOS and Android. You can also build really cool peer-to-peer games and applications. There's like support for multicast for discovering peers on your network and that sort of thing. So the sockets do get a little bit more complicated, but it's rather easy to get up and running within a couple minutes. You can create sockets, you can connect to other clients, you can listen and accept new socket connections, you can be a server, read, write, support, disconnect, destroy. And that's sort of what we use for TCP. For UDP, you bind, you receive from arbitrary sockets, send to arbitrary sockets, or arbitrary clients. And then you can join in groups for multicast. You can also get like your IP address on the particular device that you're on and figure out the state of something. So I will tempt with the video to show an interesting application that we built using the Chrome Socket API. Okay, and we now implemented the mobile version that uses the accelerometer on an iPhone. So let's see if this works.
What is on top of the box?
Yeah, that was the proudest moment of my life. All right, so that's it. Go start using our APIs, give us feedback. They're all up. This is the repository. It'll link to all the other repositories that we have that contain our plugins and that sort of thing. It'll also give you a quick instruction guide on how to get started with porting your Chromebook stuff from desktop over to mobile. Thank you very much.